Welcome to the Industrial Talk Podcast with Scott McKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
Hey there, and welcome to Industrial Talk. Thank you very much for joining the number one industry podcast in the universe that's backed up by data. Don't even begin to debate that. Backed up by data, and we celebrate here on this platform industry professionals all around the world. You are bold, brave, and you dare greatly. You collaborate, you solve problems. You're making the world a better place. Take that to the bank. Don't even debate that. That's what you do, and that's why we celebrate you on this Industrial Talk platform. All right, in the hot seat, we have a gentleman by the name of Prasad. He is with a company called Saviant. We are talking about MLOps. Just recognize machine learning, operations, and how do you leverage that? Prasad has the answers. Saviant Consulting, big time. Let's get cracking. Okay, so here's the deal. I've had a number of people say, Scott, how do you market? How do you gain traction? How do you get attention? How do you do all of that? And so, with that said, I'm putting out a series that is specifically around industrial marketing, industrial sales. I believe all of this innovation and all of this technology, absolutely wonderful. We just have to sell it. We have to market it. We have to tell the story. So I'm going to have this series that's out there, and it's going to be taking you through everything that I do and then some on how I market, how I leverage this platform, and how get that message out. So be on the lookout for that. Just got off the Zoom. I was going to say phone, but that wouldn't be the right statement. Just got off the Zoom. And IoT Solutions World Congress is a go for next year, 2024. It's going to be bigger, better than ever before. You are in, let's just say, if you're in the industrial IoT world, if you're into cybersecurity, if you're into any of the, digital solutions, this is the event for you. It's in Barcelona. I'll have all the information out there, but I highly, and I mean highly recommend that you attend. And it's next year in May. Yeah, May. And you have plenty of time to plan. But I'm telling you, it is the event to attend. And, of course, it's in Barcelona, and that ain't too shabby as well. We have on-demand webcasts. Go out to Industrial Talk to find out more. But we have one on aligning your PF curve with your supply chain strategy. That's important. We're producing one that is specific to the digitalization of utilities. What does that mean? How does that benefit the end user? That's going to be debated, and that's going to be talked about out there. We're going to also have one that is specific and wrapped around utilities again, that how do you manage all the data coming in? What are the solutions? Why is it important? That webcast is going to be something of, you got to attend that one. That's a good one. And then finally, AR, VR, all of the stuff that's happening from an industrial perspective as we start talking about augmented reality. That to me is a cool topic. So those are the four that we have planned. They will be out on Industrial Talk. And of course, on demand. I'm not going to go down the road of saying, hey, we're going to have a webinar at this time. And no, you're busy. You have important things to do. But if you're at home and you're saying, boy, would I like to learn more about data and the utilities and hear from experts, that's your time. That's why that is important. All right, let's get on with the conversation. I really enjoyed this chat. And the chat really sort of dives deep as one can go in a podcast, about machine learning, the differences between MLOps and all of the other elements associated with machine learning, and why that is important for your business. And really, small, mid, large, wheat. This world is happening. The ball, this we're moving forward. I highly recommend. When you're listening to this, take notes, stop it, take some more notes, reach out to those wonderful people at Saviant. Big time. So let's get cracking. Here is Prasad. Prasad, welcome to Industrial Talk. Thank you very much for joining and finding time in your busy schedule. And I know it's in India and it's late, and I thank you very much from the bottom of my heart. How you doing today? Tonight?
Yes, I'm doing great. Thanks, first of all, Scott, for having me here for this discussion. I'm sure I'm going to enjoy it.
You are. I guarantee you're going to enjoy it. I lay that out for you. Anyway, all right. For the listeners out there, let's get cracking with the conversation. Give us a little background on who you are and why you're such an incredible professional. And then we're going to start talking a little bit about MLOps and what that looks like. ML meaning machine learning. And then what does that look like? You've given us some insights into some use cases of how that applies. I like that. Puts a little meat on the bone. So give us a little background on who you are.
Yes, myself, Prasad Naik. I have about 29 years of experience in IT industry.
Whoa, ho. I saw that out there, and I'm thinking to myself, what, did you get started when you were 3? Life has been good to you.
Yes, I enjoyed this profession quite a lot. I started my career as a programmer, and over the years, I got opportunity to work with different clients, different industries. And for past few years, I have been designing architectures for solving customer problems. And education-wise, I have done masters in technology with specialization in data analytics in software systems.
So here's a side note. So data analytics, just FYI, I love it. I could sit there and immerse myself into data and, slicing it, dicing, and trying to make it communicate to me on what it needs to be and what's it trying to say, that type of thing. But there's a point where, back away, Scott, we got it. We're there. We're do you find yourself is it just hard to pull away being in the world of data analytics sometime?
Yes, sometimes it becomes difficult to pull away, as you rightly said. It's quite interesting to get insights from the data, and there are various ways to do that. So various ways and various techniques, tools are also available these days. So it's quite intriguing, analyzing the data and taking insights from it.
Yeah, you're running through the office with a piece of paper going, check this out. Oh my gosh, this is fantastic. It's what it's telling me. All right. Let's talk a little bit about MLOps. First off, what do you mean by that? What is that?
Yeah, MLOps stands for machine learning operations. But before going into MLOps, let's talk about what is machine learning, basically. So
you're on it, baby. Yeah, I like that even better. Let's go. Forget about that ops part.
Yeah. Machine learning is a branch of artificial intelligence that basically helps computer systems to learn new things and improve themselves using the past experiences. So in other words, we have historical data available with us. So we apply some mathematical techniques and algorithms to train the computers to forecast or predict future events using the historical data. So that is machine learning. So typically machine learning life cycle involves several steps. So first step is data collection. Second step is data preparation. So when we collect the data, it may not be in clean format. It may be missing data. It may be invalid data, or there might be outliers in the data. So data preparation step helps us in cleaning that data and making ready for further processing. Next step is feature engineering, where we try to analyze the different elements of the data and identify which one are useful for our model. Mm-hmm. So once features are defined, designed, we go to the next step of modeling. So where we identify different algorithms and pick up the most suitable algorithms to solve the problem at our hand. And then we go to the step of modeling. Once model is ready, we need to test it. We need to validate it. once we have desired accuracy, once we have good results from the model, then we can take it to the deployment stage. So all these steps.
Planning.
Yeah.
Did you say planning?
Sure.
Okay. I'm writing this down. If you're out on the video, you can see that my head's down because this is gold. I want to know. Got it.
Yeah. So all these steps are typically done manually. MLOps helps us do these steps in an automatic fashion to improve the accuracy of the process and get quality results out of it.
All right.
So there are several techniques.
Let me just sort of recap what you said. These are 7 steps. All right, listeners, make sure if you went through it too quickly, here it is. You're going to be collecting. That's number 1. 2, you're going to be preparing. You got to clean the data, whether you like it or not. It's got to be clean because you don't want to start putting bad data into your modeling. Future engineering, so all of that good stuff that happens. And then we've got our modeling, 4. We've got our testing, 5. We've got our validation, 6. And then we go into 7, planning. Did I do it?
The last one is deployment. So once the model is ready, yes, we need to put it into actual usage.
Okay, well, let's see. Don't listen to me, even though I'm a smarter person because of you. All right.
Yeah. And one important point I would like to mention here is, even though these steps look like sequential steps, ML project is often experimental in nature. Like once we define a model, we may not get the results that we want. So we may have to repeat the process of identifying different set of algorithms, modeling again, testing and validation. So this process may be repeated multiple times. So it's repetitive and experimental in nature by design.
So when you say it's pretty much iterative, you're saying, okay, we're going to take this road and we're going to just sort of see how that sort of you try to do it right the first time, or you try to get as much traction as you possibly can in your efforts in these steps. But sometimes you're going to say, hey, let's adjust it. But with each subsequent effort, do you find the time is compressed a little bit more? Like it's not as long as you've laid the foundation. Am I looking at that right?
Once the foundation is there, yes, some time may be reduced, but again, it depends on the problem, because if you choose now a different set of complex algorithms, you may have to prepare data differently. So there are a lot of factors that drive how much time it will take in the next iteration.
I'm all in. I get it. So note to self, 7 is deploy, 6 is planning, and then, of course, 5, testing and validation is step 5. That's, make a note of that. We're going to have it out all in Industrial Talk, so fear not. All right, so with all that said, you're going through this. You're working with me. We're having this back and forth conversation on what my expectations are. Take us through sort of an example of that, like a use case, like so that let's make it a little real here.
Sure. So I would like to take an example of a recent MLOps implementation that we did for a global furnace manufacturing company.
Yep.
So they manufacture industrial furnaces, and these are huge furnaces that are used for melting metals. And these furnaces use a lining inside it to give protection to the operators who are operating the furnace. So this lining gets damaged over time and as it is used, so it needs regular inspection to avoid any accidents or any damage to the furnace or to humans operating around the furnace. So we implemented a machine learning based solution for them that collected the data from different sensors attached to the furnaces and built machine learning models to predict remaining useful life of the lining. So basically, we were able to get pretty accurate results in predicting the remaining useful life, and that helped the manual inspection process was there. It was not a replacement for the manual process, but it was a aid to the manual process to ensure that lining gets replaced in time without any damage to property or human life.
Yeah, that's probably a pretty good thing. You've got an asset that's under tremendous stress. That whole furnace, that's serious stuff, right?
Yes.
So let me sort of talk to you back at what you said. Okay, so for this company, the company came to you and said, "Hey, we have this problem. The problem is that our furnaces, we don't have good insights into the furnace, and we want to be able to have greater visibility into that environment and the components of the furnace to apply proper maintenance and repair." Got it.
Yes.
How do we do that? And so what you do is you install these devices. Now, these devices, are they in that environment, or how do they? I mean, that's pretty serious. These devices are serious. How do you collect that data in that environment?
Yeah, there are multiple sensors that are installed inside of the furnaces. So some examples of the data collected is temperature, the current that is flowing, then the leakage to the ground. So there are several parameters. There were about 80 to 90 parameters that were getting collected from the furnace.
Wow.
And we had to churn out these different parameters to find out which were most appropriate for our modeling purpose.
And then from there, you're saying, okay, we can collect the data. We've got the data. We're doing 80 to 90 points of data collection. Good, got it. Then you run it through. You're running through those 7 steps, but it's important that you collect that data. Then applying some sort of a machine learning. And does that ML solution continue to just learn more and provide greater value? Is that what we're talking about?
Exactly. So that is the main point here, that creating a model one time is not good enough. There are several reasons why we need to train our model again and again. So there might be new data that gets added. There might be change in the operating environment. That is one reason for changing of data, or the data that was used for testing and validation of the model could be different from the actual production environment. So because of these several reasons, we may have to remodel again. So another case is we did the model building for one particular client. So the location and the operating conditions were specific to that client. Now, same thing if we do for furnace at other location or other client, then operating conditions could be different. So the first model that we develop may not be valid for this client. So again, we have to go through similar steps. So that is again iterative and repetitive process, and that is where importance of MLOps comes into picture.
That brings up a really interesting point that I want to sort of probe a little bit. You have to. There's so many other parameters that can apply to a certain set of data, and one is geographic location. It could be material related, how you're melting different material, whatever it might be. And all of that has requirements, parameters that have to be modeled. Can you take that scenario? Let's just use the global furnace. Well, they have furnaces everywhere. And to be able to pull that data, pull it, and then draw some sort of overview look at all of the furnaces together and draw some additional clarifications on what's taking place?
Yes, it is possible to use all the data collected from different sites and different furnaces to build a kind of global model. So depending on how similar the furnaces and their operating conditions and the geographical conditions are, such a global model may give good results, but it is very subjective to the operating conditions, the environments, what kind of usage is there. So depending on
Yeah.
that, we may have to create separate models or a global model may work. So that is why it is experimental in nature. We can't say that I build
Yeah.
a model today and it will work for all the scenarios. No, it's not like that. We have to keep experimenting and validating the
Yeah.
results.
Yeah, that makes sense. And I know there's been a number of conversations too. Is there a possibility of running simulations, like operational simulations? You've got your MLOps and what's happening. Do you have the ability to run some simulations and saying, what if we did this? What if we did this, and do some what ifs once you have that information available?
Yes, that is part of the modeling step, modeling and test validation step. We try different parameters, different features. We try different algorithms to generate the models and the results. And we have to test and validate those results to find out which model is giving us the best results, and then use that model going forward into production environment.
Yeah, and with that said, so you're able to run those simulations, optimize the results, optimize the conclusions, optimize the insights, whatever you want to do it. But then that also begs the question that things change. Assets begin to sort of underperform possibly just because, and so
Yes.
you're constantly sort of adjusting. Is that not a part of that too as well?
Yes, that's true. So we have to keep on validating the model that is deployed in the environment. And if we see that accuracy and the results are not within the defined range or within the desired range, we may have to go back to the modeling step again. We have to collect the data again, do the modeling step again, and redeploy once we get the desired results.
So let's talk a bit about, okay, we've got it. We're collecting data. We're doing our thing. We're dealing with the operations. Why is it for me as a customer, as a furnace manufacturer, why is that important to me? What benefits do I receive as a result of that? Is there some real tangible financial benefits? Of course, there's safety benefits. That's a foregone conclusion. Explain to us a little bit about why that's important to me.
Yeah, furnaces, if we take the same example, furnaces are expensive piece of equipment. So if we are able to do the maintenance in time, we would be able to prevent the damage to the furnaces. So that will avoid any financial losses. If I take another example, let's say an energy producer using wind turbines, for them, there are several applications of machine learning. One is being able to forecast how much energy a particular wind turbine is going to produce on a particular day. Now, that also depends on several parameters like the environmental conditions on that day, the operating conditions of the turbine. So again, machine learning model comes into picture. So for them, the ability to forecast energy is very important because they are supplying to the grid. So a lot of things depend on how much energy they are able to produce on a particular day or even a particular hour. Second application is similar to the furnace use case that we discussed. That is being able to predict the maintenance requirement for the turbine. So a wind turbine has several assemblies or several components. So if we are able to predict the failures of those components or remaining useful life of those components, it will help doing the maintenance on time. And typically these turbines are located at remote areas. So maintaining them is difficult. So if we know in advance what is likely to fail, then we may take precaution to replace those components or repair those components and avoid unnecessary repeat visits to the site. So that is another financial benefit.
Yeah, it's all bottom line stuff. It makes sense that it's operational uptime. It's the ability to be able to take that asset down at the right time when, let's say, in the case of the wind turbines, it's like, okay, forecast, we're not doing it. Doesn't look like we're going to have useful wind today. So let's run a replacement of something. But that only comes through the ability to be able to know exactly the health of that asset. That's how I look at it. And it's bottom line. And you want to keep those things spinning when they need to be spinning and, doing what you need to do when they're not. So one last use case. I know that we talked about the water utilities. Give us a use case around that one.
Yeah. So for this water utility, they have smart meters installed in many geographical locations. So these meters keep providing data about the water consumption for a particular customer. So it could be domestic customer or commercial customer. So these meters keep on sending the data, which gets analyzed using machine learning model to identify the patterns in the usage of water. So one important use case was to be able to identify the leakages that are happening, or uh, probably usage of water for washing machines or for uh, washing hands. So different patterns were identified using machine learning models, and that provided a good insight into the patterns geography wise. And the utility company was then able to optimize the usage of the water by providing this information to their end customers.
See, that's so important, even going forward. I just think in general that we need to be, as an industry, as being part of this industry, is that we need to be committed to pulling that information and getting that insights to make real great tactical and strategic decisions. But that's not the case. What are some of the sort of the roadblocks? I'm having this conversation. I think it's great. I think it's all doable, and it's only going to get better, right? It's only going to get more nimble. Give us a reason why people are sort of not into it. What's the pushback?
Yeah, one thing is people are concerned that this only a hype? Does machine learning adoption give us real benefits? That is one thing. Second aspect is the necessary skill set and know-how to implement the machine learning algorithms and modeling part. Third is the effort that is involved and patience that is required, particularly for implementation of machine learning applications and projects. It's not like a typical application where once you have defined requirements, you just code and test that application and you are done. In machine learning, I'm repeating this, but experimentation is an important aspect. So you need to have patience to get the results that you desire. So that could be.
Here's the reality. It's happening, whether you like it or not. And I look at it this way. You just accept it. Find the team, like Saviant. Find the team to help you with that journey, and you'll be okay. It'll help you. All right, we have to wrap it up. How do people get a hold of you? They're saying, man, Prasad, he's the man. I want to talk to him. How do I get a hold of you?
Yeah, you can reach out to me on my mail address. It's prasad.naik@saviantconsulting.com.
Good. Well, that's pretty easy. Are you pretty active out there on LinkedIn?
Yes, I am active on LinkedIn.
There you go. I'm going to have that contact information too as well. I'm going to have his email as well as his LinkedIn profile, which is probably just jacked full of insights and wisdom. But anyway, it's all going to be out on Industrial Talk. You were absolutely wonderful. Thank you very much.
Thank you, Scott. It was nice talking to you. Thanks a lot.
It's always good, man. I always like it. All right, listeners, we're going to wrap it up on the other side. You know that. So we're going to have all the contact information for our friend Prasad as well as Saviant out on Industrial Talk. So stay tuned. We will be right back.
You're listening to the Industrial Talk Podcast Network.
Another great conversation delivered with passion and enthusiasm. Prasad, Saviant Consulting. It's happening. You need Sherpas. You need people to help you on this journey. And you need to find those individuals to make that happen. Team Saviant, Prasad, definitely fall into that category of delivering incredible value, insights, and solutions. Big time. All right, again, we have events. Go out to industrialtalk.com. Events that are conference related, events that are webcast related, and of course we have all of the podcasts from just delivered by experts in their industry out there. And then, of course, finally, we're talking about all of the marketing stuff that we're going to be producing out there so that you can be successful. Hear from me. I'll be the expert as much as I possibly can. But anyway, be bold, be brave, dare greatly. Hang out with Prasad, and you're going to change the world. We're going to have another great conversation shortly.